Hello, this is a short demo that I wanted to provide to you based on the request of several students that demonstrates some of the important elements of Programming Project 3. And I'm providing this after the project is due so that you have the opportunity to wrestle with some of the challenges. And then also the way that I implement these details may be a little bit different than the way that you do them. And I also want to demonstrate the way that you would construct a fairly significant program in small steps. So let's start through this. Now, one of the things I want to do is sort of baseline where we are in the project expectations. So we have a project that's listed on the course site that requires us to work with two groups of data. One group is an array of numbers called scores, and the other one is an array of names called players. And once we import that data, then there's some requirements that we need to work with. So the first thing that it wants us to do is sort the output based on players or sort the output based on scores, and then exit the program. Now notice what I'm doing here. I have a main module, an initialize module, a read data module, and an output data module. And this is typically the way that I would start a program. And the philosophy for programming is this: start small, get it to work, and then every time you add a bit of code that should run, then run that code and make sure it works. And so what I did was obviously started the main, and the purpose of the main is to be the orchestrator for the various functionalities of the program. So I have an initialize. That's generally a scratch pad that I put in there. I may come back and add some elements to it, or may take some elements out. I know I must read the data in correctly to be able to process it. So I'll read the data, and then before I do anything with it, I will output the data. So the initialize that I use here is just a scratch pad. I put a character, I put a string variable here to hold this symbol, and this symbol is the line feed. And it allows me to put this here, welcome project 3 plus NL will feed to the next line. First step plus NL will feed to the next line. So I need to fix that. And then I have my read data. So the read data is the module that I use just to go grab the data out of the data file and import it into the arrays. And typically, no matter how sophisticated a program that you do, the first part of your program is go and grab the data. Typically, you have to clean it or normalize it, and then you can work with it through the rest of the program. So I have my typical givens that I use to read from an input file. This is a call to a function in Raptor that says I'd like to read in from a data file, and the data file is this data.txt. And then this loop right here loops through the number of times that I have something in my data file. So it says, are you at the end of the input? If you're at the end of the input, then exit. If you're not at the end of the input, then take the first item and put it in name.index, which starts as 1. So grab the first item in the array, in the data file, and put it in the array name at 1. Then grab the next element in the data file and place it into the array at score.1. Increment index, now index is 2. I come back to the top of the loop. I'm not at the end of my input, and then I proceed. So here's the data file that I used, and you can construct your data file in several different ways. But an absolute given, when you write code to read data, you must know the format and the layout of the data file. So you either need to look in the data file, or you need to construct the data file the way that it supports the operations. And this is sort of a basic data file. Typically we would have a comma separated variable data file. That's not easily accommodated in Raptor. So that's my input data file. That's data.txt, as you see that right there. So as I run this, and let's go ahead and run it, it's going to step through the operation. It's going to jump over to initialize. It's going to provide the little display, and now it'll just cycle through it. And let me, the watch window here, you can see the arrays start to build. Notice that index is increasing, and I'm fully populating my arrays. When I reach the end of the data file, then I will read no more elements, and the arrays will stay at that size for the duration of the program. Now it'll jump into the output file, the output data module, and now it's going through the loop. In this case, you don't see anything because it's not printing it to the console, but it's outputting it to a data file. So in a second, when it's done going through, as you notice, index is cycling again. As we get to index 10, then it will exit, and I will get to the end of the program. Now that I'm at the end of the program, as you can see there, then what I'll want to look at is my other data file. This is my data.txt file. My other data file, which would be in output data, is here. My other data file is results.txt. So now I need to find results.txt. Here it is. And notice I can comfortably say that I read the data in, and I'm ready to go on to the next part of the project. Now let's progress into the program a little bit. So I've made a major change. The first chunk of code that we wrote in test was to initialize, to read the data, and then to output the data. And we did that for the reasons that we just discussed. We wanted to be very comfortable, and it must be accurate that we read the data in correctly, and that we knew we could output the data, because we'll always use the output to data to check our results. What I added here was a subprogram which complied with the requirements of the project statement. Now I won't do the entire project here, but I will do the important elements that you can then take and extend on your own to satisfy the project. I think the key point here is we have parallel arrays, and whatever we do to one array, if we're going to change the order, we have to do it to the other array, or we'll lose the one-to-one correspondence, and we'll have a mix-up between which player earned which score. So we're using a sort, so we have sort player, and let me go into that subprogram. So here's the subprogram. Now, one of the advantages that Raptor has is typically the flowchart layout lends readability to the behavior of your algorithm, and it's still true, but in some cases it's easier to do a scripting language or a procedural language, because you can infer the behavior of loops by the fact that one loop is in another, and it's a little bit more difficult to see in Raptor. But let's look at this. So we have a sorting routine here, and we want to use a bubble sort, and we want to retain our one-to-one correspondence between our two arrays, our array of player and our array of score. So let's look at this. Now before we get down into the details, a bubble sort and a selection sort has one loop inside of another loop. The inner loop steps through the individual array elements, and at each point it's comparing it with the array element on the right. We're using score. If the array element on the right is less, then we swap them. But let's see where it's very easy, particularly if you're learning bubble sort for the first time, and also just coding in Raptor. It's very easy to kind of lose the bubble on what's the outer loop and what's the inner loop. So let's define the outer loop. So first of all, we have loops here. We can consider these to be for loops. We can consider them to be while loops, but they're a counter control loop. The loop control variable for the outer loop is IX. The loop control variable for the inner loop is JX. Remember the three important conditions of a looping. You need an initial case, initial condition, you need a test case, and then you need an increment. So let's see what we have here. Here's our outer loop. There's our initial condition. We set IX to 1. Here's our test case for determining whether or not to continue the loop or not to continue the loop. And down here is our increment. And notice it's IX. The inner loop is JX. There's my initial condition. JX gets 1. Here's my continuation case, or my loop condition case, and I will loop as long as JX is less than length of score minus 1. And then down here at the bottom is my increment. So I have this loop, the JX loop, inside the IX loop, and we'll get into watching it run in a second. So let's stipulate that we have a bubble sort, and that we have an outer loop defined by IX, an inner loop defined by JX, and the business of the bubble sort happens right here, where we ask ourselves, we're using this is the purpose of this particular subprogram, is to sort based on, I just realized I called it sort player, but I need to recall it sort score. So I need to retitle that particular subprogram. But nevertheless, I'm sorting it on sort score. Okay, just to be clear, I exited the recording and I renamed this subprogram as sort score. So I'm sorting based on score. So what I need to do is I need to check, just think of an array of boxes, and I want the numbers in those boxes, or the score in those boxes, to proceed from a lower number on the left to a higher number on the right. So my logic is right here, and again, this is the business case of all of this code that we see on this subprogram or this submodule is embodied right here. And what I'm doing is I'm checking, is score of JX plus 1, which means the box on the right, is it less than the box I'm looking at? And if it is, then I need to swap them. So these items right here are the swap cases. The first 3 allow me to swap the parallel array names, the elements in the parallel array named score, and since I'm swapping these, I need to also swap the corresponding points for player. And then I complete that. I increment JX. I go back around and I say, am I at the end of the score array yet? If I'm not, then I check again. So what I'm doing is I'm moving from left to right. I'm grabbing 2 elements or 2 boxes as I move along, and I'm saying if the box on the right is less than the box on the left, swap the boxes. And I have to go through that process. I have to iterate through the entire array 10 times, which is what I mean by the IX. Now there are changes that I can make to my program here, to my code, that would make this process more efficient. But I think the first time that you use a bubble sort, this is the best way to implement it. Then the next step is there are some things you can do to slightly make it run a little bit faster. Okay, so let's go through it. Let's watch the code run. And the first step is we're going to read our data in, and we can see our data here. And it's important to notice that index in this case is the loop control variable for reading in and reading out. Let me slow this down a little bit. And the next step is I move to the sort, and now I want to sort here. So what we're looking at here is the way that a bubble sort should work is the highest number in the array, every pass that I go through should move to the right, so, or in this case to the bottom. So notice the first pass through the array, as I iterate through all these loops, as I iterate through JX, notice IX is fixed at 1, JX is at 6, and it'll increment. Let me step it up just a little bit faster. And it'll increment. And as it increments, as JX gets close to 10, then the highest number should be at the last location. And it is. Now I'm on my second pass through all of the elements. So IX stops at 2, is fixed at 2. JX is incrementing from 1 to 9. And notice what we're going to see in this case, it doesn't need to do it right now because it's already happened. At that 912 will bubble up to be the second to the largest position. So now notice what's bubbling. So it'll pick 912, then it'll look through all these elements here, and it'll pick the highest one. And again, some of these naturally came in this location. So I'm watching this iterate again. So this is my third pass, IX is 3, and this allows me to step through all the elements. So in this case, 846 is iterating. and we'll see